All right, so let's look at the program in the lecture that uses the scanf function, and let's play around with it a little bit. Okay, so start from the beginning. We have two integers, integer 1 and integer 2. We then print out a message, enter first integer, maybe do that a little bit differently, and then we want to read in a decimal number. That's why I put a %d over here, and I want to store that specifically in the location of integer 1 in the variable integer 1. And I'm going to print out second message, enter second integer, and done with that. Then I'm going to read in another number, also as a decimal number, and store that in the other variable in typo integer 2. So you can see that this is where that syntax highlighting is coming in handy, because as soon as I type in something that the compiler is not recognizing, it will not, in this case a variable, it will not give it the appropriate color. I declare integer variable sum, and then I perform an arithmetic operation. I compute sum of integer 1 and integer 2, and then I want to print out the result to screen, saying something like sum is I want the number there, and that number over there is going to be the value of sum, and that's it. This should work, but it won't. And here's today's twist. Run that, and you get an error. So instead, what we have to do over here is let's take a look at those errors. It says return value ignored, scanf, and then we have these two errors. Scanf, this function or variable may be unsafe. Consider using scanf _s. The _s stands for secure. So what has happened is that Microsoft actually in its Visual Studio compiler, there is a bit of a problem with the use of scanf that can cause serious problems. I'll talk about those, what can go wrong with the use of scanf when we talk about arrays, which will be in a couple of lectures. So in order to avoid those problems, Visual Studio uses a slightly different function. It calls scanf _s, like the ones that I have just changed the scanf to. Scanf _s avoids those security problems, and like I said, when we get to arrays, I'll come back to this issue, and I'll explain to you why Visual Studio has replaced the traditional scanf that we find in C with the scanf _s. So I'm just going to run the same program, this time with scanf _s, with a secure version of scanf, and instead of going back to this play button up here, to this run button up here, what I'm going to do is I'm going to use a shortcut for that. The shortcut for this button over here is the F5 button. Okay, so after a while you may find tedious to use the mouse again and again, so maybe just use shortcut button over here. And there you go. So enter first integer, so I'm going to enter 45 for example, and hit enter. We move on to the next line, enter second integer, and I'm going to follow the same example we have in the slides. I'm going to enter 72, hit enter, and sum is 117, and the program exits. Okay, all right. Now, let me change some things around over here. So instead of simply printing out the message sum is, I'm going to put a new line after that, makes for a neater output. 45, 72. There you go. Looks a little nicer. So instead of just printing out the sum, what I want to do is I also want to print out the whole operation, like the two numbers I put in. So maybe I also want to play around with the mathematical operations. Maybe I don't just want to use addition. So instead of calling this sum, I'm going to call this new variable. I could call this result. And then I'm going to change this to result. So this is still doing the same thing. I just changed the name of the variable result to sum to the name result. Okay, and which means now I can really do any math operation between integer 1 and integer 2. And let me just show you again. So there you go. First integer is 3, second one is 15, and the sum is 18. Result is 18. Now, instead of just showing what the result is, maybe I want to print a slightly more friendly message over here. Maybe say result of, and then I want to show the number integer 1 and integer 2, and the operation between them, and then I want to put the result value over here. So I can do that too. I can basically have multiple placeholders like this, when values of variables will be substituted when this string is printed out by printf. And what I have to do over here now is, so basically I have 1, 2, and 3 placeholders in here, which means I have to provide 3 variables over here. So integer 1, second one is going to show integer 2, and sorry, integer 1, integer 2, and the result of the mathematical operation. Okay, so I can run this again, and let's say first integer 16, second integer is 13, and the sum result of 16 plus 13 is 29. So that looks much nicer. And in the same step, you now know how you can put in multiple placeholders in a string and display the values of multiple variables in a single printf statement. Now, we are doing addition over here right now. I could change this to something else, such as multiplication. Remember, in the multiplication is done using the asterisk character. I'm going to replace that over here in the string, the plus sign with the asterisk as well. So let's say now, if I run this again, the program is going to ask you for 2 integers. So let's say I'll give it 3 and 5. But this time the result, what I'm doing is multiplication. So 3 times 5 is 15. And if you don't remember, this is not actually doing multiplication in the printf statement. If I want to make it look like a multiplication sign, like an X, I can do that, because it doesn't really matter. Remember, this is just a string. The actual multiplication is happening on the previous line. So let me try that again. Let's see, this looks even nicer. So what was it? 4 times 6. 4 times 6 is 24. And if you don't want to put is over here, want to put an equal sign over here, because that makes it look more natural, you can do that too. Remember, the equal sign over here is just like any other letter, like any other character. So 5 times 7, 5 times 7 is 35. And you can try out other operations. So for example, subtraction works the same way as addition. And there you go. So this time I'm going to subtract integer 2 from integer 1, store that in result, and then print out all these numbers. 3, see that? So first integer is, let's say, 10. Second one is 5. 10 minus 5 is equal to 5. Looks good, right? Now I could also do this whole thing. Actually, before I move on to that, let's also try out division. Something funky over here. So let me show you. So remember, I'm dealing with integers, and the result of dividing one integer, let's start with something simple. 8 divided by 2 is 4. Not a problem. But let's say I try something stranger. So over here, I am dividing 10 by 3. What should be the answer? If you do this on paper, you would expect the answer to be 3.3333, right? But try it over here, and the answer of the result of dividing 10 by 3 is 3. The reason is that when you divide one integer by another, the answer will be an integer. You have a remainder, of course, but that's not visible over here. If you want to do work with fractional numbers, that is a whole different deal. For that, you need a different data type, to which we will get very soon. So instead, if you want to know what the remainder of dividing integer 1 by integer 2 is, ten divided by 3. Oh, sorry. I think, yeah, have to use an escape character, I think, over here for the division, for the percentage sign. No, still not. So actually, here's another exception, kind of something you have to remember, just like a different escape sequences. If you want to print a percentage sign, you have to type percentage twice, percent, because otherwise percent is taken as the start to a placeholder like we are using here for integer 1, integer 2, and result. So let me try this again. Hit F5, and there you go. First integer is 10 divided by 3, and the remainder is 1. Okay. All right. One other thing that I want to show you is that the use of this result variable over here is kind of unnecessary. Actually, in addition to being unnecessary, we're using up 3 lines over here to declare 3 variables. I could do the same thing on a single line. Let me show you that first. So instead of declaring the result variable down here, let me delete that like this, and I can create all 3 variables, integer 1, integer 2, and result, using on a single line of code. I can do that too. You can see it works just as well as before. 13 divided by 4, and the remainder is 1. Now I could actually, in this case, I could actually skip the use of the result variable entirely. Let me show you why. Instead of, because this is such a simple calculation, let me comment this out. And this is, you can see this is where commenting comes in handy. If you don't need a line of code temporarily, or don't need it at all, instead of deleting it, you can just comment it out like this. So we want to print integer 1, integer 2, and the result of integer 1 mod integer 2. You can put the whole operation over here. So what will happen now is, in this string, let me replace this by mod. just a string mod, the way we would write it on paper if we were doing math. So right now what will happen in this printf statement? This is a placeholder for integer 1. This is a placeholder for integer 2. And this is a placeholder for the result of this entire mathematical expression, integer mod integer 2. The remainder of dividing integer 1 by integer 2. Let me show you, let me demonstrate to you that this also works. And in doing so, let's say, let's make that 50 divided by 4, and the result, the remainder is 2, right? 50 divided by 4 is 12, and the remainder is 2. So this is a way to accomplish the exact same thing, but saving one variable. I want to show you one last thing. Recall that the main method, the main function that we're using, is specifying that it returns an integer value. Okay? And see over here that whenever we're running a program, well, with whatever the inputs are, let's say 50 divided by 4 again, we get a message over here. So after our program runs, .exe, that's ch2 underscore using scanf.exe, that's the name of our program, exited with code 0. The value of this code over here is basically the value returned by the int function over here. If I want to return something other than 0, let's say I want to return the value of the value that I'm calculating over here. So let me go back in, restore the result variable, and let me change this back to multiplication. And let me change this back to the result variable. So before ending the main function, what I can do is I'm now going to send back or return the value of result, an integer, right? It's an integer. We declared it as an integer over here. Notice also that whenever I click on a variable anywhere in the code, the IDE automatically highlights all locations in which it recognizes the same variable. Okay, so that's another nice feature that editors, specifically the Visual Studio editor gives you. You want to look where integer 1 is being used, click on the variable. So it's nice. Okay, and you can click any one instance and it'll automatically highlight like all other locations where it's being used. So what I want to do is I want to do this, I want to take the input from the user, calculate the result, print out the result to the screen. But after that, when this main function returns an integer value, I want that integer value to be the result that I've just calculated. So let me try that. So remember, we're doing multiplication, so I'm inputting 3 and 4, and the result is 12. But look at the next line over here. It says exited with code 12, which is the value of result, which is the value that I am returning over here. Okay, now traditionally what we do is the return value from function, if it's a very small function like this one that you're looking at right now, usually the value that we return is the work product, the value that we have calculated. But when functions are more complex and there are lots of things that can go wrong inside a function, what functions return are not their work product. They return the work product using other mechanisms. Instead, the value that they return are what we call error codes. They're still numbers, usually numbers, But those numbers let the user know whether the function worked correctly or whether something went wrong somewhere inside. That's why the return value of main over here is being referred to as a code. It's being called a code. It's really just a number though. So I think that's it for this section, and I will next time we'll look at a couple of other. We'll work a little more with this piece of code that we have over here, and we'll try out some other data types other than integers.